Okay, you've been talking about conditional statements in section 2.2 of your pre-AP geometry book, and a conditional statement is an if-then statement. If you do your chores, then you get an allowance. And so today we're talking about a biconditional statement. And a biconditional, the definition is a single true statement that combines a true conditional statement and its true converse, and it uses the words if and only if. And I didn't leave a space for you on your worksheet for you to write this sentence, but I just wanted to give you an example of what a biconditional statement is. An example is, your birthday comes once every 4 years if and only if your birthday is February the 29th. And so what that means is it's true as it stands. Your birthday comes once every 4 years if your birthday is February 29th. And the converse is true. If your birthday is February 29th, then it comes every 4 years. And so to be biconditional, both the original statement and the converse of the statement must be true. Now, a good definition for a biconditional is, or there are three, it uses clearly understood terms that are commonly understood or already defined. Biconditional statements are precise, so I'm going to put is precise, meaning we avoid words such as large, sort of, and almost when we use precise words. And number 3 is reversible. Meaning that you can write it as a true biconditional statement, that you can switch the order, in other words, use the converse, and it's still going to be a true statement. Okay, here's where a lot of writing starts to come in this section, because this numbers 1 through 5 say each conditional statement below is true. Write its converse, and if the converse is also true, then combine the statements as a biconditional statement. So what first of all we need to do is we need to write the converse. If a number is divisible by 2, then the number is even. The converse is if a number is even, then it is divisible by 2. So we read this converse and we determine whether or not it's true. If a number is even, then it is divisible by 2. That is a true statement. And because the original statement, the conditional statement, if a number is divisible by 2, then the number is even, because that is true and its converse is true, we can write a biconditional. And the biconditional statement looks like this. A number is divisible by 2 if and only if it is even. And so we use this if and only if because we can read it backwards. If it is even, then the number is divisible by 2, or a number is divisible by 2 if it is even. And again, only biconditional statements can be written if both the original statement and the converse are both true. All right, you hit pause and you try numbers 2, 3, 4, and 5. All right, so you check your answers for numbers 2, 3, 4, and 5. Take your time. Make sure you understand how we worded it. Remember, the blue is the biconditional. The reason 3 and 5 do not have biconditional statements is because the converse, the statement that you wrote, was false. And when the converse is false, you cannot write a biconditional statement, because in order to be biconditional, the original statement and the converse must be true. Number 6 and 7 say to write the two statements that form each biconditional statement. Okay, and so what we really need to write is the original and its converse. Okay, so for number 6, one of the statements is if two lines are perpendicular, then they intersect to form right angles. The other statement that you will need to write is the converse. If two lines intersect to form right angles, they are perpendicular. Then they are perpendicular. And I'm going to use this symbol because that symbol means perpendicular. So you wrote the original and its converse, and that's what forms a biconditional statement. Now you try number 7, hit pause, try number 7, and check your answer. Number 7, the two statements that you should have are as follows. If a whole number is divisible by 3, the sum of the digits is divisible by 3. And the other statement, if the sum of the digits of a whole number is divisible by 3, then the number is divisible by 3. Number 8, your two statements should be, if a whole number is odd, then it is not divisible by 2. If a whole number is not divisible by 2, then it is odd. Number 9, if a person lives in Alaska, the person lives in the northernmost state in the U.S. If a person lives in the northernmost state in the U.S., the person lives in Alaska. And finally, numbers 10 through 13, it asks you, is the statement a good definition? If not, explain. And so it says two rays intersect if and only if they lie in the same plane. And so we have to determine if it's good or not. And this one is not, and I understand that you may not understand or you may not get just yet two rays and in the same plane. And so I'm going to talk about it. But this is no, not a good definition. And because the reason is because the rays could be parallel. And if they're parallel, they're not going to intersect. Or they could be pointing in opposite directions. And if they're pointing in opposite directions, they are not going to intersect either. All right, you read number 11 and you determine whether or not it is a good definition. Just try it. You may not be great at it, but try it. Hit pause and try it right now. Number 11, a redwood tree is an evergreen tree that grows very tall. This is not a good definition because it is not reversible. Meaning, not all tall evergreens are redwoods. Number 12 and 13, you try. Hit pause. 12. A rectangle is a quadrilateral with 4 congruent angles. That is a good definition because in order to be a rectangle, it has to have 4 congruent angles, and those angles are all going to be 90. And then number 13, a hexagon is a polygon with exactly 6 sides. That is also a good definition. Now, what I want you to do is I want you to practice your 2.3 worksheet, and you may not get all the way finished, but just get started, and we will just do the odds for right now. 2.3 worksheet, just the odds, and when you're doing this, you are allowed to work with your partner.